Friday, August 8th. No, the 9th. Friday, August 9th. And it's like, I don't know, 7 o'clock. We're back at the wiring. And I realized something that I want to have trailer brakes. I mean, a trailer connection with trailer lights. And in this mess, there are left, right, stop, and marker light wires that I've pulled out from the auxiliaries that were back there. So I'm going to have to find out which ones they are and put them back in. It won't be that hard, I don't think. I'm pretty sure this dark brown is the marker light. I'm pretty sure that this red is going to be the brake light, and I'm pretty sure that these two blues are going to be my directionals, just because I don't have that many choices in colors here, right? The purples, like really sure all these purples with the white stripe are for dome lights, so that eliminates those. Then the only thing left is these tans, which I'm pretty sure all the tan wires have to do with inputs to the computer, like for the sash warning, the roof hatch warning, and the back door warning. And the back door had two circuits. One was a warning beeper, and the other one was it turned on the backup lights, of all things. So if you open the back door, you would automatically have lights, white lights back there to walk around in the dark or something, which I guess that's pretty cool, but I'm not going to put that circuit in. So what's interesting is I've got these two rather heavy white wires, which I would swear would be grounds, because all the grounds have been white so far, and it's going into that cluster of stuff. So I'm gonna have to follow those and see where they go, because I mean, like that sweep right there, it goes behind. That's a little bit hard to get to. I don't want to unbolt all that stuff yet, because then it's going to be a real rat's nest over here. I think I'm just going to work with messing around with that. So what I want to do also is double check what I'm saying about all these tan wires being the beeper warning system. And the easy way to do that would be to turn the key on and put a ground on these things. But I want to be careful about putting a ground on these circuits. If it's a hot circuit for something else, it might pop a fuse or hurt something. So what I'm going to do is use my test light and put the alligator clip on a ground and use the probe and see if it'll cause my beeper to go off. And the reason why I think I can do that with using the test light bulb, the light bulb and the test light to be a ground path, is because early in my ownership of this bus, the rear door leaked and water got in the switch, and the water was enough to carry the current and make the backup lights come on. So I don't think it takes much current to trip the circuit. So I guess for starters, I'll chase these big white ones down and see what they do, because if they're ground wires, I mean that's one thing that's kind of weird what they did on this bus. They've got ground wires going the clear length of the whole bus to supply a ground to the lights in the back or something, right? But they've already got up there at the top a whole bunch of ground wires grounded to the body. It's like, why didn't they just save 30 feet of wire and put the ground over there? You know, I don't know. Unless these grounds are going through something to control the ground circuit as well as the hot circuit. Got a little bit of a kink there. I mean, this looks like a number 12 wire right here. I hope I can save it. I can always tape that thing up. All right, so let me get started here. I got the key in the garage. I'll go get my test light and start probing around and see if I can figure out some of these mysteries. All right, so key on. Okay, so I got my test light hooked up with the alligator clip on the ground, and so when I touch the tip to a positive, the light comes on. So what that means effectively is that anything I touch with the tip of my test light is going to be grounded out with the resistance of the bulb in series. So I just tested this a minute ago. Door open solenoid. This one's called door switch. Let me see if I can hold the phone here with my knees. So when I take my test light and touch this little guy, it makes the dome light come on over my head. So this was the wire that was grounded whenever the door was opened to make the dome light come on over my head. Now when the key is off, let me double check. Okay, nothing happens. So this is a very usable switch for me, a usable circuit for me, that I may decide to put a door switch on, right? So whenever I open the door and the key is on, the interior light will come on. I might want that. I don't know, probably not. But just in case I do, now that I've identified that wire, I made myself a little sticky with my label maker, door switch dome light. So I'm going to stick this on the wire. Okay. Just throw those guys on the floor because I can. And stick this over kind of like halfway and halfway on there. Sorry about that. There. So that circuit's been identified. This one we already know it's a door open solenoid, and this is a door closed solenoid. Alright, so we got that figured out. Let's see, what's this other one here? Sash. So watch what happens. Key on. Let's wait for that beeper to stop. Alright. When I touch this to a ground, it's making that little light come on. That used to be a beeper. Okay, I replaced it with a light because it was beeping like hell and it was annoying, and I was trying to figure out what made that circuit work. But whenever we put a ground on this wire, it makes that thing come hot, and it's going through the computer. It's not supplying a ground for that light. If that were the case, my test light would illuminate when I do that, because the test light bulb is smaller than, or about equal to, in current flow to that light. And if they were, let's just say for example, the little bulb in my test light was the same bulb as the bulb over there in current, which they're very, very close, I'll tell you. All right, what would happen would be the current, the resistance of one would reduce the current into the other. All right, so there'd be voltage drop between them, and bottom line is they would each be running on 6 volts instead of 12 volts. And since this is not coming on at all when I touch the wire, that's telling me this is going into a high impedance circuit, a high resistance circuit in the computer, one of the computers, right, to tell that circuit to turn on that light. So the reason why that wire is cut is because I knew it was a sash wire because it had this label on it. Not door switch. I'm sorry, the other one, it said door sash. The reason why that one's cut that one, is because I am not able to follow this through to this computer. It's going into a different harness. It's going in down here through this harness. So there's either up under the dash another one of these guys, which I don't think there is, but there might be, or it's going through the firewall because there's like 2 or 3 of these under the hood. So in order to help clear the rat's nest down here, I decided to just cut it because I was pretty certain it was for a system that I'm not really interested in using. I really don't think I'm going to use any kind of warning circuits or anything to where that, you know, I can have a warning light come on in my cab, right, or a beeper if something is grounded. To me, that's just one more opportunity for something to be a power draw and kill my battery if I left something open. And I would prefer, if I'm going to have any of those circuits, to do it on the house battery, not the chassis battery. That's the main difference, okay? So let me keep on keeping on here. Next thing I find that's kind of interesting and cool, I'll share it with you. All right, we're doing a little bit more discovery here. I opened up this harness and I found, I mean, I've seen these before, but I found them again here. There's some unused connectors. This one is called rear air solenoid. This one is called forward air solenoid. And this one is called air cross arm. All 3 of them are connected together on one wire, which makes me think that this is a ground circuit. What's weird is the ground circuit, supposed ground circuit, is going into this, which is my fuse panel. So what I wanted to do is verify if this is a ground, because if it's going to an air solenoid, it's a circuit that can take some current, and I'm not worried about putting a test light on it. So I took my test light alligator clip and hooked it to a positive source. So now anything I touch my point to that's a ground will make my light come on. And then what I did is I went in here and I touched just the ground terminal and the light came on. I can't duplicate this with one hand very easily, especially looking through the damn camera. There. So the light is on and I'm touching the ground circuit. Now the key is off. Let me turn the key on. Alright, so the other wire is not a ground. This one is a ground. I do not want to short those together because I might pop a fuse or something. But let me see. I know if it's a cross arm, it's not going to have any power on it. There's no power here. You would have to turn a switch on to get power there. But hey, I'm just plinking around, okay? We're doing some discovery. How about this one here? There's power on that one. No. And no. So all those are going to get power when something is activated. And what's kind of interesting is this one that's called air cross arm. So we got a ground wire on one side and the other side goes right into this computer. So that's going to have to be, you know, it could be an input. These could be inputs that tell the computer when those things have been, like if you would have had micro switches in each of those devices, when the device was extended, it would put a ground on the circuit and tell the computer, hey, cross arm is open. I'll bet you that's what it is because they're tan wires. I bet you they're inputs. And there's a whole bunch of tans right here, tan with a white stripe. I think these are all inputs. Maybe they're not inputs. I don't know. I'm kind of lost. It'd be great if I had a wiring diagram. No, these are the inputs. These are the switched inputs. Bank B and Bank A. Those were where all the switches were hooked onto. These might be programmable as an input or an output or a switched circuit. I don't know. These two big white wires I pulled out, they were definitely ground wires for, I'm pretty sure, the rear lights, because each big wire was connected to two little wires in the middle. So they gave me 4 little wires. So these are, since they're a larger wire gauge, probably for carrying a load like lights, not just a switch to trip the computer, these are probably the ground wires for the auxiliary tail lights back there. So I'm just leaving those intact, and I already did check them, and they are ground. So, all right.